So, one more of these. The first three we did kind of worked out really nicely, and it was easy to get to the V's. And then there was a piece that canceled when we initially did our V sub each time. What I mean by that is like it had these V's everywhere. It was clear that I wanted to do Y over X's. And then in each of them, this piece canceled, right? So I'm going to give you one now that doesn't have quite isn't quite as obvious or as easy to get through. And before I write it, I will tell you that there are probably many, many, many ways algebraically to get through this problem. Um, but I'm gonna do one that sort of just like it just makes sense to me in terms of how to do it. It also, the way that I'm going to do it demonstrates some things that we will do later in this course that become like a very good technique to use. So now that I've rambled, you guys are like, yep, let me give you a problem. It is x plus y times y prime equals x minus y. Is it linear? I don't know. No, it's. Can you tell why it's not linear? It's not linear because the y and the y prime are being multiplied, so I can't use mu. And then if you were to try to separate things, I just think it would be a total mess. So here's the deal. Instead of just like doing it, give it your best shot. And I think that there's like a moderate likelihood that you'll need some help getting through it. But I would like you to go ahead and try it first. So hit pause, try it. Okay, the answer, and keep in mind this is one for which there are many answers that you could write. I think the best, most pure answer is x squared minus 2xy minus y squared equals a constant. Now it's possible that you have something that's algebraically equivalent to that looks nothing like it. But boom, I'll show you how we get there now. All right. So first step, you could go a variety of ways. I'm going to divide and get the y prime by itself. So I get y prime equals x minus y over x plus y. Now, given that I know v sub with the same v's, the v equals y over x, because that's all I told you I was going to give you, I need to get y over x's. And the most obvious way to me is to pull out an x factor in both top and bottom of the fraction. What I mean by that is we get y prime equals, pull out an x, and then fill in what I need. Now, if we were to do a whole bunch of these as board work in class, you would get really used to this technique. But this is the last of these problems we're going to do. So as I do this, what you need to say is, what do I need to put here in order to make this top line exactly the same as that? Well, I definitely need a 1 because that would give me this. And then minus, what would I need to have here such that if I were to multiply an x in, I would just get a y out? Well, I would need a y over x. Do you see it? Because if I distribute this in, I get that. Same thing on the bottom. I get 1 plus y over x. And then these cancel. And now you should see, oh, there's the v, right? So now we're going to sub that v in. So y equals, I'm going to let v equal y over x. That means vx is y. That means dv dx is equal to v sorry, I did that wrong. Dv dx times x plus v is equal to dy dx, right? Okay, so now sub in v, whoops, v, and then boom, goes in here. So let's do it. I get dv dx times x plus v is equal to this fraction, 1 minus v over 1 plus v. Now, this spot, it is not as convenient as the other ones we did because this little v right here, in all the other ones, it was like, oh, sweet. There's like another v there. They just canceled. It was gone, right? We don't get that here. So what I need to do is, these are almost always separation of variables. Why are they almost always separation of variables? It's because this x and the dx have to get off to that other side, and we have to multiply and divide by them, and that's really the only way to get this piece away from that piece. That's why we often see separation of variables with these. So what I really want to do is take this v and get it with these and make it so that I can separate them and move them over to the v side. So I am going to write dv dx times x equals 1 minus v over 1 plus v minus v. Now, you may say, okay, that doesn't help, and you're right. This is the technique that shows up a lot later on in the course, when we do the Laplace transform, actually. So I got this, and I need to get them together, right? Well, in this case, the easiest way to do that is to find a common denominator, which in this case is 1 plus v. So if I multiply this by 1 plus v over 1 plus v, then I can put these two pieces together. And that gives me dv dx times x equals 1 minus v over 1 plus v minus, I'll distribute that in, you know what I'm going to do? I'm going to write plus, and then I'm going to write minus v squared all over 1 plus v. Why did I do it that way? Because I didn't want to drop a negative with my distributive property. So that gives me dv dx equals 1 minus v minus another v minus v squared all over 1 plus v. And you know what? We got two negative v's there, so let's just write minus 2v. Now, you may see it. At this point, it's a quick separation of variables. Now, this problem was designed to be integratable when I do this quick flip, and we're lucky in this case, right? It's not always going to be like that. But watch. If I go and separate variables by, I'm going to multiply by the reciprocal of this fraction, and then, I dropped my x, and then move the dx and the x over. So what that's going to give me is 1 plus v in the top, and then I'll write 1 minus 2v minus v squared. dv equals dx over x. So you might be able to integrate that without just looking at it, that left side. The right side's easy, it's an ln, right? Well, actually, I'll just tell you. The left side, it's an ln. Do you see it? The bottom derives to a multiple of the top. So can you, without doing u sub, figure out what, it's like what the ln would be, what would be inside of it, and what would be the coefficient out front to balance everything? I'll do it right here. I'm going to let u, I know it's a u sub and a v sub, right? Well, just be glad that I didn't give you the one that has a u sub and then a v sub and then a w sub because we ran out of letters. It's true, I got it, but you're not getting it, don't worry. So I'm going to let u equal 1 minus 2v minus v squared du is negative 2 minus 2v. Notice if I factor a negative 2 out, I get 1 plus v equals du. And then this, bam, is at right there, negative, my bad. So I get negative 1/2 du equals 1 plus v. So this would be the integral of 1/2 negative du over u equals integral dx over x. So that gives me negative 1/2 ln absolute value of u. I'm just going to sub this in right now, this guy right here. So I get 1 minus 2v minus v squared equals ln absolute value of x plus c. Okay, now I like you could like, this is where you're like, wait, that's the same as this? Because I've done my integral step, right? Now I just gotta get x's and y's and stuff. So you could like sub your x's and y's in at this point, but it would get really messy. One thing that I want you to take note of is that there's an ln here and an ln here. So I want to get it into a spot where I can e to the everything to get rid of the ln's, because I should be able to do that. First step would be to multiply everything by negative 2. That would give me ln absolute value 1 minus 2v minus v squared equals negative 2 ln absolute value of x plus, I am going to write c and c1, and let this would have a negative 2, so let c equal negative 2c1. You don't have to do that, but I just like to do that. It makes me happier. Now, plug it, yo. Ln absolute value 1 minus 2v minus v squared equals ln absolute value x to the negative 2 plus c. Now, e to the, that's going to give me, the left side simplifies nicely, 1 minus 2v minus v squared. The right side is stuck. I want to try and cancel it out, but the c's in the way. But remember, I can go e to the ln of the absolute value of x to the negative 2. I can actually drop that absolute value at this spot, but we're not going to talk about that. Times, why can I do that? Because it's always going to be positive in here. Times e to a c, right? And now I'm going to do another let c2 equal, let my new c equal e to the c2, and I'm going to back tag that with 2's, like that. So now the c that I have is just, it'll be better, right? So that gives me 1 minus 2v minus v squared equals, all right, now look, this whole thing right here, which is being multiplied by this, is now my new c. So I'm going to write that c, and then that gets multiplied by this thing. But look, e to the ln of this, that cancels and gives me x to the negative 2. Now, I'm running out of time. 1 minus 2y over x minus y squared over x squared equals c over x squared. Multiply everything by x squared on both sides. I get x squared minus 2. This gives me yx minus y squared equals a constant. And that, after all that, is what I have up here. I hope you see it. I won't give you one like this on an exam or anything like that, but I did want you to see what a more complicated one looks like, and I wanted you to see this step of smashing them into the same fraction, taking this v without that and then putting them together, right? It's a good strategy to make things actually workable. Anyway, thank you, and goodbye.